Hey everybody, today we're going to be looking at 4.2. This is kind of a continuation of what we did last time. Sorry for the camera, I'm having to use the one on my laptop. But anyway, so we're going to be looking at the exponent rules that you should have done last year. But we're going to be combining a lot of them, unlike what you did last year. So last year, probably what you did is you probably looked at these rules, looked at examples of one of the rules, maybe two. But today, the idea is to kind of bring them all together. So just as a reminder, whenever we have a to the a negative power, we can rewrite that as 1 or any variable, obviously. And we can rewrite it and move that negative to the bottom. And when we move it to the bottom, it becomes a positive. And that is the negative exponent rule. So this is a big D. Okay, for this next one, we have the multiplication happening between our two variables. Since we have multiplication, again, not division, or not addition or subtraction, multiplication, we can bring that exponent inside. So we can have a to the fourth, b to the fourth. Okay, next one, we have the power rule. We have a power to a power. So we're going to multiply. So we're going to get a 3 times 4, which is 12. We have product rule here. A 3 plus 4 because of this multiplication. So we get 7. Division, we can bring the exponent inside too, but it goes to all the parts. So a cubed, b cubed. And then for here, whenever we are dividing, we are just subtracting. So a to the fourth. And then anything to the 0 power is 1, except for 0. So just going through these really quick, the power of a power is here. The power of a product is going to be here. A 0 exponent is obviously the one as the 0 exponent. Power of a quotient is here, and F is here. Okay, so kind of bringing all that together and what we did last time together with those rational exponents. I have multiplication happening on this first one, so I can add the powers. So I'm going to get 5 to the 6 over 3, or 5 to the second, which is just 25. We can always use a calculator to check these. So if I go over to Desmos, 5 to the second is 25. But we started off with 5 to the 2/3 times 5 to the 4/3, and I get 25. Again, feel free to use Desmos to double check these. I'm probably going to skip that just to save some time. Okay, same thing with this second one. 1/5 plus 4/5 is going to be 5/5, or 1, and anything to the first power is just that thing. For this one, we're going to multiply. So 4 to the 2/3 times 3. The 3's really cancel, so we're left with 4 squared, or 16. Same thing here. 4/2 is just going to be 10 squared, or 100. Subtracting 8 to the 5/2 minus 1/2, and I'm subtracting because we're dividing, and our bases are the same. Now, it is important that the bases are the same. If our bases aren't the same, especially and also with the multiplication ones, then these aren't going to work for us. So we're ending up with 8 to the 4 over 2, or 8 squared, or 64. Okay, now this one's a little bit funky because I'm going to end up with 7 to the negative 3 over 3, or 7 to the negative 1, which is really just 1 over 7. Okay, moving on and bringing these ideas together, because really what this says, remember, this kind of brings both what we did last time and this time together. So I've got 3 times, and this is really both to the 1/2. But remember, multiplication with radicals, I can bring everything together and say the square root of 36, which is just 6. The square root, this is going to be the cube root, sorry, of 125, which is just 5. This is going to be the cube root. And really what they're doing here is they're going, hey, okay, well, 3 to the third fourth root times, if I really wanted to break this down and show you exactly what was happening, right, then 3 over 4 times 1 over 4. I'm multiplying, so I just add. So it's going to be 3 to the 1, or just 3. And that just continues on. Here we're dividing. Division distributes over radicals. So I can say square root of 98 over 2, which is the square root of 49, or 7. Okay, and I can continue that on. I'm going to skip the rest of these though, just to save some time. So there's those definitions again for you. And then this just asks you to use the properties. I'm more worried about you being able to actually use them versus being able to name them. So I'm going to go ahead and go on again. So this is where it gets tricky because here some of the exponents aren't nice for us. They don't add up nicely. So we've got to make sure we are good with adding fractions. So here I've got 2 to the 3/4 plus 1/2. Okay. So I've got 2 choices here. I can just look at here, which is probably the easier choice. So I'm just going to look at this for a second. So 3 over 4 plus 1/2. Okay, I can rewrite this 1/2 by multiplying 2 over 2, because if I multiply something by 1, it doesn't change it. So 3 over 4, because 2 over 2 is 1. 2 over 4, so I get 5 over 4. Okay, so then this one simplifies down to 2, 5 over 4. Okay, and then we could take that and go through and get an exact answer if we or an approximated answer using Desmos. Okay, same thing here. Really remember, if there's nothing there, it's a 3 to the 1. So 3 to the 1, and then 1 minus 1 over 4. Okay, taking this part, looking at it, going, okay, well, 1 is the same thing as just 4 over 4 minus 1 over 4. So that's going to give me 3 over 4. So then I have 3 to the 3 over 4. And we're just trying to do as much simplifying as possible. For here, I'm going to look at the inside here real quick. Since I have the same power here, I can actually drag this out and say 20 over 5. Multiply these powers. I'm going to get 3 over 2. This simplifies down to 4. 3 over 2. And we could actually take this one a little bit further, because if I redistribute that and say the square root of 4 cubed, that should be 8 for us. Okay, now on this last one, I need to be careful because there's a lot that looks like it can happen. It looks like, okay, it kind of looks like I have the product rule here, but remember, I need the same base, and I don't have the same base. So really all I'm going to be able to do on this one is 5, 1/3 to the 3, which is just 1, times 7 to the 3/4. And honestly, and then, I could throw that in a calculator and get an approximate answer, but that's about all I can really do with that one. Okay, Product property, again, says that as long as I have the same base on my radical, I can multiply those out. And then it distributes over division as well. Okay, so these just simplify it out. 12 times 8, get 216. Okay, and I can do that because I have, again, the same base, have the same base. Okay, and then these are some good rules to know that you're in the simplest form. You don't have any n powers as factors other than 1. The radicand doesn't contain fractions, and this is the most important one, no radicals appear in the denominator. Okay, so for example, and we'll look at that on, I think, this one. But for this one, a good way to do these to see if you can take anything out is to make a factor tree. So I take 5 out, right? And I've got 2, 7. Take a 3 out, I've got 9. Take another 3 out, I've got 3. Okay, I've got 3 3s, and I need 3 to be able to pull out. So 3 square root of 5. Now, for this next one, and this is where it gets tricky, because my guess is you probably haven't seen rationalizing a denominator before. So I'm actually going to make this one a little simpler, and I'm going to say just square roots for right now. And let me make just a different example. Let's go with the square root of 3 over the square root of 5. So this is a completely different example. We'll call it C. But to rationalize a denominator, because I can't have a radical in a denominator, it's against the rules, can't do it, not allowed. What I need to do is just multiply by 1. And the 1 I'm going to multiply by is what's in the denominator. And I'm going to keep doing that until the radical goes away. Well, the top then is going to be square root of 3 times the square root of 5. And then the bottom is the square root of 5 squared, because it's really just the same thing times itself. So the top becomes square root of 15, and then these cancel out, so I'm left with 5. So that's how we would rationalize the denominator on that one. Go ahead and pause it if you need that. I'm going to erase that part, though. So looking at the one we have, though, it's not just squared, it's to the 5th power. So what you really want to do on these ones, especially if it's not to a nice power, is take it and go ahead and take, okay, well, for the top one, that's not really going to do anything. It's not really going to matter. The bottom one's the one that's going to matter. Now, I can rewrite 8 as 2 times 2 times 2, or 2 cubed. Well, that means I need to get from 3 to 5, which means I need 2 more square root of 2s. And again, as long as I have the same thing in my numerator and my denominator, I'm just multiplying by 1, and that doesn't change anything. Okay, well, when I multiply the top out, I get the square root of 5, or 5th root, sorry, of 7 times, and sorry, these should be 5th roots as well. The 5th root of, and I want to bring this back in, so I'm going to say 4 over the 5th root, and then product rule says, okay, well, I'm just going to add 3 and 2 and get 5. Well, now these cancel. Multiply these, I'm going to get 28 5th root over 2. Okay, so the idea with rationalizing denominators, we want to try to get rid of that radical. For the most part, you're going to see the ones like the example I gave you before, that C example. Okay, now this is where it gets tricky, so make sure you're paying close attention to this one. I've got a radical in my denominator here. I need to get rid of it, but I can't use the trick that I just used. So I'm going to use what we call the additive, or the complex, the conjugate of this radical. So that being said, a conjugate is, so like I have a plus here, a conjugate is going to be 5 minus square root of 3. So I've got 1 over 5 plus the square root of 3. I'm going to multiply that by its conjugate on both the numerator and the denominator. Okay, well, the nice thing here, at least on the top, is that 1 times anything is just that thing. Now, this should look very familiar from what we did in the last one. If I think about this and I put this in parentheses around this, I really have A and then B's and their difference. So this is going to be that difference of squares. But just to show you how this would work, I've got 5 plus the square root of 3, 5 minus the square root of 3. This is going to be 25. This is going to be 5 square root of 3. This is going to be negative 5 square root of 3. And then I'm going to have negative 3. Okay, well, these ones will always cancel if you're using a conjugate. What's going to be left on the bottom is 25 minus 3, or 22. Okay, so when you need to use a conjugate, typically all you really need to do is square the front one, square the last one, and then subtract them for the denominator, not for the numerator. And it's okay to have a radical in the numerator. It's just not okay to have it in the denominator. Okay, so simplifying these ones out, and again, I want to be careful because now I'm adding, not multiplying. So this is like saying I have 1 of these guys and 7 of these guys. That's what that 7's telling me. So here it's just going to be 8, 4th root of 10. Here, same idea. I'm adding, so 12, 8 to the 1/5. Okay, here I can't quite add these, but let's look at this 54, because I can't really do anything definitely with that 2, but let's look at that 54. Take a 2 out, left with 27, 3, 9, 3, 3. I can take a 3 out, and I'm left with a cube root of 2. Well, now I can do something. I'm subtracting 1, cube root of 2. I'm just putting that invisible 1 there. So then I'm going to have 2 cube root of 2. Okay, and then this is just more practice doing all the things. Again, this one, I would want to use that complex conjugate, so 6 plus the square root of 2, 6 plus the square root of 2. So then I'm going to have 36 minus 2 on the denominator, or 34. On the numerator, I do actually have something I need to multiply here. So I'm going to have 18, because 3 times 6 is 18, plus 3 square root of 2. Okay, and the rest of these kind of just play like the other ones that we did. So I'm going to skip those for now. For this one, this is a good one. So 64, 2, 32, 2, 16, 2, 8, 2, 4, 2, 2. Okay, and I need to bring them out in threes. So I can bring out 2 sets of 2's, or a 4. Now this y to the 6, remember we can rewrite that as cube root of y, and I can bring that 6th out, which then means I can rewrite that as 4y to the 6 over 3, or 4y squared. Okay, for this top one. And another way to think about that is I have 6 y's, and I need to bring them out in pairs. Well, I had 6 2's here, right? For this one, same idea, 4th root of x to the 4th, which is just going to turn into x, because I have 4. I can take out 4. 4th root of y to the 8th. I've got 8. I need to take them out 4 at a time. Well, I can take out 4 twice, so y squared. Okay, this is that same idea. Okay, with this 4, I can't really take anything out because that's just going to be 2 squared. Here, though, I can take out 5 of these a's, and it turns into 1 because of the 5th root, but then I'm left with 3 still under there. Here, I can take out 2 sets of b's, but I'm going to be left with, and that's 10, right, that I need to take out, but I'm going to be left with 4, and then I can take out all the c's. here, x. I'm going to have to take them out in threes. I've got 8, so I can take out 2 sets, which would be 6 of them. That means I'm going to be left with 2. Okay, but again, I can't have a radical in the denominator, so I need to rationalize this. Okay, well, I already have 2. I'm just moving that 2 outside. That's fine. But I need one more. So I'm going to multiply by the cube root of y, cube root of y. So I'm going to have x cube root of y. I had y squared already. I'm getting another y. So then I'm going to end up with x cube root of y over y cubed. Okay, I'm going to need some room for this last one, so if you need to pause, go ahead and pause. Okay, for this last one's kind of funky. So I want to try to cancel things out as much as possible. So I can cancel out just looking at the numbers, I'm going to have 7 because I can reduce those by 2. Looking at just the x's, well, I can subtract those, right? And I'm going to have x, and it's really to the first, minus 3/4. The y is not going to do anything, so it's just going to be y to the 1/3. Now this z here, since it's a negative, I can bring it to the top and make it positive. Okay, so this one actually didn't turn out as bad as I thought it was going to be. 1 minus 3/4 is just going to be 1/4. Y to the 1/3, z to the 6. Okay, and again, just a lot of the same. This one I'm just adding 11 square root of y. Okay, this one I want to subtract. I can see I want to subtract, but I need to get them looking the same first. So I need to pull things out in threes. I can't do anything really with that 2. I've got 5 z's, so I can pull 3 out. And I'm left with 2 inside. 54, I think we did earlier. It was going to be 2, 27, 3, 9, 3, and then 3. So I can pull 3 out. Can't really pull any z's out. And I'm left with a 2z. So now my bases are the same, so I can subtract these. So I'm going to have 12z minus 3z, so I'm going to have 9z square root of 2z. Okay, again, these are a lot, just kind of the same thing over and over again. What can I take out? How many of the things can I take out? It doesn't really change. Okay, so that's kind of it. Again, you've probably seen all these rules before, but you haven't maybe combined them. So that's one thing to watch out for on this one, is that there's a lot of combining on these different sets. Please make sure you are coming if you need to for tutoring. I'm available before and after school for tutoring I'm not, but someone is available before and after school after tutoring every day. And then I'm available on Fridays during that RTI time. Please make sure you're coming. Please don't wait till the end of the quarter again, especially since it's going to be after the break. Let me know if you have any questions, and I will see you next time.